Good evening, Bearcats. By the way, 7th period, I really enjoyed the video that you guys made. It was pretty fun and entertaining. Very creative. Very impressive. All right. Anyway, go Bearcats. Hope we're beating Kingwood tonight. And if you're not watching this tonight, I hope you're at the game. And I will miss you tomorrow in class. All right, this is A2. This is just actually review out of the appendix of our book. This is skill review on exponents and radicals. I've just copied and pasted here all of the properties for exponents and radicals that you're supposed to know. This might be a good page actually just to print out at some point if you wanted. I will... If you want to do that, remind me and I'll try to download it as just a Word document if you can't. I don't know if you can print from a video or not, but that might be helpful to you just to have that as just in front of you. Or make sure you have them written down. Most of these you probably are very familiar with. A few of them you might not, especially some of the special cases for odd and evens when you have a radical and an exponent in the same problem underneath the radical. So that would be like number 6 over here. And here's a common special case. So, except for those, you're in pretty good shape. And we won't do a lot of those. But I do want to make you aware of them. The rest of the video, I'm just going to work some examples. I'm not going to work a lot. I'm going to work some, and then you can work through that. There are many examples before the exercises in your book. I'll put the problems you're supposed to do up on the board tomorrow, and hopefully by Monday you are all caught up and we'll have a good review before we test next week. All right, let's get started. First problem we're going to do is we're just going to start with some simple. This is just evaluating involving simple radicals, and I'm just going to work through problems. So this is just examples. First example I'm going to do is just basic square root of 36. The basic square root of 36 would just be 6, not plus or minus 6, just 6. We have a negative of the square root of 36. Well, the square root of 36 is 6, therefore your final answer would be a negative 6. We have the cube root of 125 over 64. We can break this down into 2. We can make this to the cube root of 125 over the cube root of 64. The cube root of 125 is 5 because 5 times 5 times 5 is 125. And the cube root of 64 is 4 because 4 times 4 times 4 is 64. So 5/4 would be your final answer. All right, here's another simple one. We have the 5th root of a negative 32. All right, you can have an odd root of a negative number, just not an even root of a negative number. Remember, a cubic is like snaky looking graph, goes on both directions, so your x values can be positive or negative. And remember, a square root, an even root, goes one direction. So that's why an odd root is okay for a negative number. This would be negative 2 actually, because negative 2 times negative 2 times negative 2 times negative 2 times negative 2 would be negative 32. All right, there's explanation. Next, we're going to take the 4th root of negative 81. The 4th root of negative 81, there is no real number to take this to the 4th power. And we're not going to do imaginary since we're just simplifying this. So, not real. Not real. All right, let's move on to a few more examples. This is where we're going to use properties of our radicals. So here's some more examples. We have, let's say, the square root of 8 times the square root of 2. You could simplify the square root of 8 before you multiply, or you could multiply and then simplify. Most of the time I'm going to multiply first, unless the numbers are really large. So 8 times 2 is 16. I'd have the square root of 16, and we know the square root of 16 is 4, so that would be our answer. Here's another one. Parentheses, the cube root of 5 cubed. Well, you should remember that a cube and a cube root would cancel each other, and your answer would simply be 5. Here's another one. You have the cube root of x cubed. And as before, the cube and the cube root cancel. Doesn't matter if that cube is underneath or outside the radical, they will still cancel one another. In this case, we have x. And then here's one of those special cases where you have the 6th root of y to the 6th. You have a 6th root, a power of 6. It does cancel, but it would be the absolute value in this case. Because of the double positive here, it'd be the absolute value of y. And the reason is because this y right here could be positive or negative, and once you took it to the 6th power, it would automatically be positive, and then you could take the 6th root of a positive number. And so that is why the absolute value. All right, let's move on to a few more examples. And again, like I said, there are additional examples in your book. I'm not going to go through every one of them, but I am going to go through some, and rather quickly as well. All right, let's talk about combining radicals. Combining radicals. Let's take these. These are going to be, I'm not going to do as many, and these are going to take us a little more time. So if I have 2 square roots of 48, and I want to subtract 3 square roots of 27. Well, we know when we combine things, we have to have like terms, and right now we don't have like terms. What would make these like terms if underneath the radical were the same number? So you'd have to have the same radicals to be able to combine them for them to be like terms. So what's underneath the house would have to be the same before you can combine them. Let's see about simplifying. Again, I'm not sure all the methods that you've been taught to simplify radicals. I think we've talked about in here. I just want to go back over. I like to use a prime factorization. Since these are both square roots, we're talking about prime numbers, and we would be extracting pairs, any kind of pair. So here's what I do. I go over here and I go 48, and I just do prime factorization. It's kind of like an upside down division. It's prime numbers only, smallest first. 2 would make this 24. Divide by 2, I would get 12. Divide by 2, I would get 6. I divide by 2, I get 3. Since it's a square root, I'm looking for pairs. I got a pair of 2's, and I got another pair of 2's. So that 2 comes out of the house. That 2 comes out of the house. If I multiply them together, I get 4 out of the house. This 3 doesn't have a friend. He stays home. So I have 4 roots of 3 is the same as the square root of 48. I already had a 2 here. Be really careful. So this is like 2, and then it would be times 4 root 3. 4 root 3, please understand, is the same as the square root of 48. We've just rewritten it simplified. 2 times 4 would be 8, and we would get 8 square roots of 3. Let's see about 27. So if I take 27, I can't divide by 2, but I could divide by 3 and get a 9, divide by 3 and get a 3. I have one pair. That 3 comes out of the house. This guy stays home. So I already had the minus sign. I already had that first 3. And now the square root of 27 is equal to 3 square roots of 3. So 3 times 3 would be 9 square roots of 3. Now I have like terms. They're both square rooted. So I have square roots of 3. So I have 8 minus 9. That's a negative. So negative square roots of 3 would be my final answer. And go Bearcats. Next, let's take one with some exponent or some variables as well. Let's take a look at one similar but a little different. We're going to take a cube root, and we're taking the cube root of 16x. And we want to subtract the cube root of 54x to the 4th. 54x to the 4th. Again, not like terms, and until they're like terms, we really can't do much about it. So let's see what happens. Let's go over here and do our prime factorization again with 16. Divided by 2 is 8. Divided by 2 is 4. Divided by 2 is 2. Because it was a cube root, we have to take out groups of 3. Those 3 2's get to come out as 1 2. This 2 has to stay back under the house. So this becomes the 2 times the cube root of 2, and the x, there's not 3 x's, so the x just stays to stay underneath. So now we have 2 times the cube root of 2x. We're going to go ahead and subtract, and we're going to simplify 54. So 54 divided by 2, 54 divided by 2 is 27. And you can't divide by 2, but divide by 3 would be 9. Divide by 3 would be 3. And so this is a group of 3 3's. We have to have a group of 3 since it's a cube root. So 3 comes out, and then the 2 stays home. So we would have 3 times the cube root of 2. We have like terms now because we have cube root of 2. Oh, sorry about the x. We have x to the 4th. So we have x times x times x times x. I'm not going to do it this way every time, but I just want to see. There's a group of 3. That one x comes out. This guy has to stay home. So it's actually 3x on the outside, and we have this 2x on the inside. Since we now have like terms, we can actually subtract them. And we could write them this way. And this is something you probably did not see in Algebra 2, even in pre-AP, written this way. Since we have 2 minus 3x, but they're both cube roots of 2x, we can write it this way. We could write 2 minus 3x times the cube root of 2x. Okay, so 2 minus 3x, cube roots of 2x. That's a little different. I'm sure you haven't seen that, but I'm sure you can handle it. So, go Bearcats. Next, let's look at rationalizing some things. Let's take this first one. So, more examples. So, we're going to take 5 over 2 times the square root of 3. And we want to rationalize our denominator. That means we're going to get rid of that radical. We're going to do that by multiplying by the square root of 3 to get rid of it. So if I multiply by the square root of 3 in the bottom, I'm also going to multiply by the square root of 3 at the top. 5 times the square root of 3 gives us 5 root 3. In the bottom, be careful, that's 2 times. The square root of 3 times the square root of 3 is simply 3. So 2 times 3 is 6. So we have 5 square roots of 3 over 6 as our answer. Let's look at another one kind of like that. This time we're going to say 2 over the cube root of 5. 2 over the cube root of 5. Okay, the only way to get rid of that is for us to rationalize. All right, to get rid of a cube root, you have to have 3 5s underneath the house. So we need more. Remember a while ago when we multiplied, if we multiplied the cube root of 5 times the cube root of 5, we'd have the cube root of 25. That would not be a perfect cube. We really need 3 of them. So we're really going to multiply by the cube root of 5 squared. And we have to do that at the top, the cube root of 5 squared. If you don't quite understand that, take a look over here. If we took this and we had the cube root of 5 times the cube root of 5 squared, the cube root of 5 squared would be the cube root of 25. So the cube root of 5 times the cube root of 25, you would multiply the 5 and the 25, and you would get the cube root of 125. The cube root of 125, we discussed this a little bit earlier, is simply 5. And we've cleared our radical out. So basically, you could have said the cube root of 5 times the cube root of 5 squared and written it this way. That's the cube root of 5, the first and the second power, so that's the cube root of 5 cubed. Cancel out your radical, and that is 5. Okay, so both of those kind of help you mathematically understand what happened. All right, so in the bottom now we know we're going to end up with just a 5. At the top we're going to have 2 cube roots of 5 squared, which is 2 cube roots of 25. And since we can't simplify that any further, that would be our answer. All right, let's work a couple where we're changing from radical form to exponential form. We'll start with a couple of easy ones. So these are just a few more examples for you. So we have the square root of 3, which we could write as 3 to the 1/2 power. This is a square root, so you can imagine there's a 2 in there, and this is to the first power, and it's always the root is in the bottom, and the exponent is at the top. So let's take another one. What if we have the square root of parentheses 3xy to the 5th? Okay, this is a 2 in there. We don't write it, but it's a 2. So you could write this as with a little 2, and you could write this as 3xy to the 5 oops, can't write that, halves. Remember, the root goes in the bottom. And one more example like that. We have a 2x on the outside. We have a 4th power, or the 4th root of x cubed. So this is going to be a little trickier here. So I'm going to keep my 2x. I'm going to change that to times x to the 3/4 power. And now I have the same base. This x is really to the first power. If we have the same base, we can add the exponents. So this is really 2x. If I want to add 3/4 to 1, this 1 really becomes 4/4. That's the same as 1 times x to the 3/4. I'm going to keep the base, add the exponents. I have 2x to the 7/4. And that would be your answer. Again, that's probably something that you might not have seen last year. All right, you can also go backwards. You can change things from what they were backwards. I'll do one of those. So you could have had x squared plus y squared all raised to the 3/2 power. Okay, that's a square root. That's on the bottom, since the 2 is in the, that would become the root, and it would be to the cubed power. So we could have written it like this. We could have put x squared plus y squared. We could have taken it as a square root. That would get rid of this, and this could be written either to the cube power up here at the top or inside here at the bottom. Both would work. All right, let's go on to our last. We're going to simplify a few rational exponents, and then I think you'll be ready to work on your own tomorrow. So let's take a look at the first one. This is our last examples. So we have parentheses, -32 to the -4/5 power. Okay, the next thing we're going to do is rewrite it. So we're going to write the 5th power of -32 all to the -4 power. Okay, well first let's just figure out what's happening inside. The 5th root of -32 is -2. So now we have -2 to the -4 power. Don't like negative exponents. That is really not a good thing in math. So we don't like that. So we can write our number over 1 and move the exponent down below and make it positive. So we can rewrite this 1 over -2. We'll keep the -2 in parentheses to the +4 power. Well, -2 times -2 times -2 times -2 would be a positive value, and that value would be 16, and that would be your answer. All right, 2 more examples, and I'm setting you free to do work on your own. Let's take a look at this one. This one we have 9 power of a cubed. Okay, we can rewrite that. Remember, 9 would be the base. A to the 3/9 power. Well, a to the 3/9 is the same as a to the 1/3 power. And then you could actually change it back, and this would be the 3rd root of a. So the cube root of, sorry about that. The cube root of a. And you could leave it like that. So you can go back and forth to simplify your answers. All right, final problem of the evening. Let's take a look at one that's a little more complicated. Here we go. I'm going to get a new sheet of paper, last one of the night. We're going to take 2x minus 1 to the 4/3 power times 2x minus 1 to the -1/3 power. All right, the first thing, we have the same base, we're adding exponents. So 2x minus 1, and that would be 4/3 plus -1/3, or minus 1/3. So you have 2x minus 1 to the 3/3 power, which is just to the first. Wow. So we really just get 2x minus 1 after all of that. Now, one thing that's really, really important. You have to be careful, because these roots, not roots, but these factors to powers, you can't have this. This works with zero, not with zeros. If you go back and look at your beginning of all your properties, the factor couldn't be. This is true. You can add the exponents as long as your base is not 0. So we do have to go make a note about a restriction. Our x value in this case could not be 1/2, and that's kind of important that you include. Could not be 1/2. So that's simplified. It could not be 1/2 because you can't add the bases if the bases are equal to 0. All right. Hope you have a good evening. I'll miss you tomorrow. Have a great weekend. I hope we beat Kingwood tonight. And go Bearcats.